All right, now I've taken what we've got on this side over here, and I just took this. I prefer when I'm doing an integration to move this denominator up into the top. So all I did was move that up so we have -3/2, so it just looks a little bit cleaner. Now it's time to actually integrate this. So it's not terrible if we start to look at it. We have some things that are constants. 4 is constant, epsilon naught is constant, sigma, the density, is constant, z is constant. Isn't that the distance from the center of the disk out to point P? That's not going to change. We got a variable here. R squared is not constant. Then here, not or not. Now, if we look here, this R, in this particular formula, if you look at this R, this R is actually the same R as little r in our other formulas. So if we go backwards in time and take a look at our original equation right here, R here, that R that we're using is the radius of the disk as we move outward. So if we look here, this R in this formula is actually little r in our disk. So if this actually was the size of the disk, that R, big R, is actually now the position of the ones on our disk. So this, in actuality, is little r. All right, now, if we look here, we go to integrate. So we've got a lot of constants, this and this. And I purposely left this 2r dangling out here because we're going to need that for the integration. All right, so I'm thinking about integrating something along these lines like here. So when I look at z squared plus r squared, we're going to have to make some corrections here for the integration. If I want to use the power rule, if I want to use u du, for example, and then use that power rule, I've got to get this in a form that I can actually do that. So let's see what we have. If I do a u substitution, I'm going to say that u is equal to z squared plus r squared, and that's my u. Now remember, I've tried to get this into a form where I can actually look in the back of the book, and they always say du in them, and they have all the little things there. So what I'm going to need to do is get this and make a conversion of sorts, du relative to dr. So this establishes the relationship between the one in the book and the one I'm left with out here. So if I can get this in the form of the one that's in the book, now I can use the power rule. So what is du, and what is dr relative to du? So what's the derivative of u with respect to r? Well, let's see, z squared, there's no, z doesn't count, there's nothing there. And the derivative of r squared is actually 2r. So if we look here, du is equal to 2r dr. All right, now if we look up in our formula, we're kind of smart to leave the 2r dr here, because isn't this actually du? All right, and what is this? Z squared plus r squared, isn't that just u? So now we have it in a form now of something that we can use the power rule on. So by leaving the 2r out here, we would have had to put that back in and reinserted it to get the integration to work, but I just left it in that form originally, trying to be a little slick about it. Okay, so when we look at this, we now know that the electric field strength is going to end up being 1 over 4 epsilon naught, and let me clean that up a little bit there. All right, and then we have sigma, we've got z. Now using the power rule, we're just going to add 1 to this particular one, so instead of -3/2, we're going to end up with z squared plus r squared to the -1/2 divided by -1/2. Looks like that. All right, so that's our solution to the integral z squared plus r squared to the -3/2. All right, this of course is du, so that's eliminated because we now have it in the form that we wanted it to begin with. Now, if we establish some boundaries here, all right, for the disk, all right, we start out, let's say, from 0 out to how far? How far do these r's, these radii actually go? From the center, 0, all the way out to, big R. And that big R is the edge of the disk, the size of the disk that they gave us. So we now have a nice little integral here that we can solve and then plug in those values, which we'll do next.